Hi everyone, this is Python Osmosis, episode 48, the screencast, whose Python references can sometimes be quite weak. I'm Ryan Shea, and in this episode we'll be talking about standard library, weak references. Okay, so far we haven't ever had to think too much about memory management, garbage collection, and our program kind of going out of control with the amount of memory that it's using. For the most part, what happens is as soon as the last reference to an object is deleted in Python, the garbage collector comes in and cleans up that object. And this works great, but imagine if we have objects that are quite huge and we want to have a cache of those objects. This is just one example where you'd want something called weak references. So we're going to do import weakref and GC. GC is the garbage collector. Now let's create a new class, and let's just pretend this class used up a whole bunch of memory. In this case, it won't, but def __ init __ self value self.value equals value, and then we're going to have __ repr. Just going to have a printable form of this object, self, and that's just going to be return stir of self.value. Okay, really simple class here. It just takes a value. So, but imagine this was something that was just really big and we wanted to be able to clean it up, but we still needed the ability to reach in and get a cache. The problem is if we create a dictionary that's a cache of all of these classes, all of these A-type objects, then we have a reference to them, and there's no way that the garbage collector can actually clean up that memory, even if nothing else is pointing to it other than that cache. So let's create a new instance of this A object, A. We're going to pass 10 into it, so now we have this object that just that prints out 10 for us. We want to cache that because it was so fabulously memory consumptive. So let's make a weak reference dictionary. So you instantiate that dictionary, and now you can just treat this like a regular dictionary. D of primary equals A. Now normally what Python would do in this case is that's a new reference in memory that points to A. So D of primary, it points to the memory address of A. In this case, it doesn't actually create a reference at all. That's what a weak reference is. So if I looked at d.keys, I do see that primary is in there. But now what can happen is I can say del A, so I tell Python explicitly delete that object. I force the garbage collector to run, and so now I know it's really, really gone. Even though I had a reference to it I had sort of a link to it in theory in that dictionary, but because it was a weak value dictionary, there wasn't really a hard reference to it. So it allowed the garbage collector to go ahead and clean up anyway. Now if I print D of primary, I get a key error. That no longer exists. It just sort of automatically cleaned it up from my weak reference dictionary. Pretty useful, nice to have. Think about using weak references if you have something where memory is running out of control. That's all for now. This screencast is directly inspired by the official Python tutorial by Guido van Rossum at python.org.